Hello everyone, this is a video talking about section 11.2 where we're going to be doing the hypothesis testing with means this time, whereas 11.1 of course we were talking about proportions. And here we will actually be making more of a distinction between the dependent and the independent styles of taking the samples. So in the case of 11.2, we're only talking about the dependent kind where the data were what we were going to call matched pairs, where whoever is in the first population will determine who's in the second population. So this is going to be a lot of times it's the same person can be a member of population 1, and then they will be matched with their own data from population 2. And this could also be, like we talked before briefly, maybe if you're studying twins or something, the twins should be matched together and stuff like that. And here you can see some of the notation that we're going to be using, where we will have a different kind of a subscript than we've had before. Now we're going to be talking about this thing that's called mu d, which this, of course, the mu has to do with the mean, and then the d is talking about a difference. So what we're going to be talking about is the mean of the differences between the two different data. So there's going to be, for example, for population 1, and then there will also be population 2. We can have, for example, data point 1 for this guy, and then data point 1 for this guy. Maybe I'll call it y1. Then these two should be matched together, and so their difference, which will just be d, maybe I can even call it d1, is going to be the difference x1 minus y1. And then we can do that, and we could actually put that into something. I'll call these list 1, list 2, and list 3, because this is how we would have it set up in our calculator, that going down the list up until whatever is our sample size, we will have those differences. And then we're going to be doing our hypothesis testing, talking about this L3 column, which is just all of the differences. And what we will be able to come up with is this thing mu d, which is going to be the mean of list 3 in this case, the mean of all of these differences. And this list of differences, which are all just the data points here, are the differences between the two data points with list 1 and list 2. They can have their own mean, which we will call d bar. They can also have their own standard deviation. And then mu d, of course, this will be for the population because it's mu. The one that goes mu bar, that will be the mean of this list, but this is just a sample, so it should get the one that goes bar, like the d bar. And the one that has mu d, this should be the population, or the difference. I wonder what is the most reasonable way to state it. The population difference, the differences of the population, let's say mean of population differences makes the most sense. And then we're going to be setting up our hypothesis with the null hypothesis being that the difference is 0. So the difference between population 1 and population 2 is 0. Or else we can have, in the case of the two tail, which is not equals, the right tail, which goes greater, and the left tail test, which goes less. But it's all centered around 0 because what we're talking about is the difference, whether there is a difference between the two populations. And we will be using, in this case, the t-test, because of course means always go with the t-value. And then we will be using list 3. We will set it up to where list 3 has all of the differences. And so why don't we see what we're going to be dealing with. We can have, of course, if we want to manipulate, for example, which population is supposed to be greater than the other one. For example, we'll say, well, does the husband tend to weigh more than the wife, or does the wife tend to weigh more than the husband? We would just keep in mind the context as far as whether we're expecting the difference to be positive or negative. And so why don't we see actually our first example here. It says in a low-speed crash test of 5 BMW cars, so apparently our sample size is 5, the repair costs were computed between an authorized repair center. So if you go to probably the actual BMW dealership, they can do the repairs, Or if you go to the independent repair center, so if you go to the whatever type of collision repair center or whatever, is there sufficient evidence at the 0.01 level of significance should support the claim that the independent center has lower repair costs? So we're wanting to test whether the independent center has the lower repair cost. In this case, if we were just to take the authorized repair center to be list 1 and the independent repair center to be list 2, if the independent repair center has a lower cost, then what we're checking is, right, we're taking something that's a larger number minus a lower number. If we do this L1 minus L2, we're going to put this into L3, and we're basically expecting to find that those differences, the mean difference, we want it to be, in this case, positive or negative. You should think about it. We're checking whether, and in this case, we're actually going to set up the null and the alternative hypothesis based on this. And what we're always checking is we're testing for the population. But of course, we're going to make our assessment based on what happens with this sample. But we will put here the mean difference for the population. If they're the same, see, we're checking whether the independent center has a lower repair cost, but in general for the null hypothesis, we're always going to say that the difference is 0, that there's no difference between getting the repair done at the authorized center or getting the repair done at the independent center. The price should have no difference. The alternative in this case, we're checking whether the independent repair center has a lower cost. So if we take this difference, it should be positive. So we're checking whether this is a positive difference. That will tell us that the authorized is more than the independent one. So in this case, we will actually have to go into our calculator and do the stat edit because we need to use these lists. So I need to go up and clear out whatever data this was. And then we're going to go into L1 with the authorized. We've chosen that. And of course, it doesn't matter which one you choose to put into L1. You would just use that to make your determination whether it's going to be right tail or left tail. You would just have to switch it if we switch these lists. We've got our 5 data points there, and then the independent center goes with these numbers, and then 297. And now what are we dealing with? We have, let's see, we have all of our data in there. Oh, I know what we should do. Why don't we go to list 3 as well? And we want to make list 3. See, I highlight list 3 in this case because I want to use a particular, and I have to hit enter so I can get the little cursor to come here. I want list 3 to be the difference between L1 and L2. So we want L1 minus L2 into this one. And we should be able to just use these buttons. List 1 minus list 2. This will populate list 3 with all of these differences. And they're looking pretty positive. So we can make maybe some guesses about this one. But in general, I will just continue with filling out this data from the problem. The alpha level is 0.01. We're going to need to use that in our test. And now since we're doing mean, we're going to need to go to stat tests and use t-test because mean goes with t. And in this case, we actually have, we don't want to use the stats because see, we don't know this data, or I mean to not use the word data and stats like that. We want to come to data because we're actually using the data set in this case. Mu0, we should always pretty much have 0 here for our purposes of the matched pairs. Because of course, mu0, that's this number that we put. This is mu0. That's always the number that gets put into the null hypothesis. And then the list, it's asking which list has the data that we're going to look at. In this case, we need to use list 3 because that has the differences. Frequency is not really applicable. And we're checking whether it is greater. We're using the one that goes greater than 0. So greater than this one, greater than our number mu0. And then we should be ready to calculate this one. And there we have it. We got a test statistic goes 3.215. The p-value goes 0.016. Yeesh. It was a pretty small p-value. You know, this test statistic is kind of big, 3. But we actually had a very small level of significance, 1%. And so we didn't really make the cut in this case. The p-value that we got is greater than the 0.01, which this was our alpha level. And in the case that the p-value is more, because of course the p-value is talking about probability, there was actually more of a probability to get this sample in the event that there is no difference. I know it's kind of based on the way that we've done it before with the p-value versus the picture. We're not drawing picture in this case, but we were checking the p-value. The probability had to be less than the level of significance in order to reject the null hypothesis. So we cannot reject in this case. Probably, if we had a larger sample or something, this sample is very small, and even though the differences are always positive, it's just not enough to make the conclusion. So we should say there is not sufficient evidence to conclude that. And what are we concluding? We're concluding that this claim, we should put this one in here, the claim that, and then here, the independent repair center has lower repair costs. We want to put that here, that the independent center has a lower cost. It's not possible to support the claim with our evidence. Sufficient evidence, and it can even be possible to make this a little bit more robust by saying at the alpha equals 0.01 level. That can be even a little bit better. And so we will see some more examples using, especially for 11.3, where we're going to be talking about the independent samples. We'll be doing something totally different for that one, but in general, that's it for this video. We'll carry on with some more examples, and especially 11.3 in the coming videos. Thanks for watching.